in a straight line. So in this section, we're going to look at how to calculate velocity. So our equation is our average velocity is our change in displacement over our change in time. So we can write that change in as our final position, that's df minus di, over our change in time. You'll also see it written like this. You'll have, let's try this again, velocity with a line over it equals change in d over t. So all of those mean the same thing. So my first example problem is a space shuttle is traveling at a speed of 7,700 meters per second. How far does the shuttle travel in 2 hours? So the first thing to realize is that this speed is not changing. So we have an average speed of 7,700 meters per second. How far is we want to find delta D. So I put a question mark instead of an X because we have so many variables. And how far does it travel in a time period of 2 hours? Now notice that's in hours and our velocity is in seconds and our SI unit for time is seconds. So let's change that to the number of seconds in 2 hours. So we know there's 3,600 seconds in 1 hour. So we have 2 times 3,600, which is 7,200 seconds. So I have another blank slide, so I'm going to go to the next slide. So the first thing you want to do in physics when you're starting to work these problems is list all your variables. Things will get more complicated, and as you list your variables, it really helps you to determine which equation you want to use. At this point, we only have one. So we have, we have V average is the change in D over time. Now we're trying to solve for distance or displacement. So time and time, I'm just rearranging my equation like we did before. I like my variable to the left, which means I want you to have the variable to the left, and it's velocity times time. You might remember it as rate times time for math class. So our velocity is 770 meters per second times 7,200 seconds. We multiply those two together, we get a change in distance. Now it's a space shuttle, it's going really fast for 2 hours, so it's going to be a big number. 2 sig figs times 10 to the 7th meters. So when you put this in your calculator, you're getting something like 5.54. Look all the way to the end of your number. It'll say e to the 7th, and then I'm just changing it so I have 2 sig figs. And once you're satisfied with your answer, make sure you've actually solved what you've been asked to solve for and put a box around it. Our next one says, at an altitude of 300 kilometers, the circumference of the shuttle's orbit is 42 million meters. So 42 million meters is 42 times 10 to the 6th meters in improper scientific notation. So that's a distance. How long in hours does it take the shuttle to go around the Earth one time? So I want to find time, eventually in hours, and the distance it's traveling is going to be 42 million meters. And we know its average velocity is 7,700 meters per second. So in this problem, we're looking for time. So let's go to our basic equation. My basic equation is average velocity is delta D over time. This time, we're solving for the time variable. So I want to multiply both sides by time and divide both sides by velocity. Looking at how your units cancel, now we have time all by itself, and on the right side, the time will cancel, so we have our change in placement, change in position over average velocity. take care with this rearrangement. I see it done incorrectly very frequently. So time is going to be equal to 42 million. Now, I don't bother to change it to proper scientific notation until the end of my problem, if necessary. It usually works out by the time you do your mathematics. Now notice I'm dividing by meters per second. So first let's worry about the number. And my number, the magnitude is 5,454. The units, notice the meters cancel. It is seconds, you know that because it's time, but let's just look at those units for a second. So we have meters over meters per second. So I'm going to make that a fraction, and this is going to be meters over 1. Take your denominator and flip it and multiply. That gets your meters to go away, and you're left with seconds. So that's our unit analysis for the units. Now, two things. They asked us for hours, and we have a lot of numbers. We probably only need 2 sig figs. So let's change our seconds to hours. So we have 54 seconds times 1 hour has 3,600 seconds. So that's 1.52 hours. Looking back at your problem, we should have 2 sig figs. Our original velocity had 2. So think about it. I bet you got it. 1.5 hours to go around the Earth once. It's kind of cool, huh? All right, let's look at some graphs. So, position time graphs. Noticing this graph, we have position. So it's starting at 0. That's our origin. A car's driving at a steady rate because it's a nice straight line, nice constant slope. Notice that it stopped in this middle part, and then it drives again. And if it's a different slope, it has a different rate or a different velocity, because position over time is velocity. So looking at this picture, I don't know if you're familiar with these canal boats. In England, they used to be used for carrying goods up and down the country. Now a lot of people just rent them and go on little vacations, and you get out and you have to open or close the locks in order to raise or lower the water level so you can go to the next section. So each one of these things is a lock, and the couple who's in the boat just waiting for the water to fill so their boat can go to the next lock. So here's a graph of a boat in this situation, and we want to know how many stops it makes. So whenever it's at the same position for an extended time, or you have a horizontal line on a position time graph, you know that it's stopped. So we have 1, 2, 3 stops, because that's where it's horizontal, and so it's remaining at 40 meters between 3 and 4 hours. What is the boat's average speed for the whole trip? So we have to break this up a little bit. Let's call this A, this part B, this part C, and this part's D. So if we look at part A, well, if we want to look at the whole trip, that's what I want to do. Notice the total distance, that's our final distance, is 100 meters. Our initial distance, DI, was 0. So we know our delta D. For time, our T initial is 0 hours, and our T final is 10 hours. So we're going to look at the whole graph for this part to find the average speed. So average speed is your change in position over your change in time. So we have, for our average speed, df minus di is over change in time. So we have 100 meters minus 0 over our final time was 10 hours minus 0. So the maths is easy. It's here to show you how to do stuff. And we get 10 meters per hour. Nice and slow, huh? It's a vacation. You go slow. So there's, oops, I kind of dropped. It's kilometers per hour. That makes more sense. Now, on the next question, same graph, what is the highest speed the boat reaches? So that's why I was labeling A, B, C, and D. So the highest speed, we need to know the speed in part A. We'll call that VA. We'll find VB, VC, and VD. So notice in part A, the final distance is 20 meters, and it traveled that far in 1 hour. So for part A, VA is equal to 20 meters minus 0. There's our DF minus DI, and it's 1 hour, and those are kilometers. Let me make that correct. 20 kilometers minus 0 over 1 hour, and you get 20 kilometers per hour. Let's check VB. In VB, it goes from 20 to 40, and that takes from 2 to 3 hours. So going the long way, VB is, it's going to 40. There's your DF, minus 20. For the time period, we're at 3 hours, minus, you started at 2 hours. Now you can take those shortcuts, and you can see here that it's still 20 divided by 1, so it had the same average speed in part A. So let's do this part a little bit differently. In C, oops, you can see 60 minus 40, so you know this top part is 20, and the time period is, again, 1 hour. So I'm taking just some allowed shortcuts to see that that speed in part A, B, and C are all equal. In part D, it traveled a further distance. This time, it's at 100 meters at the final and 60 at the beginning. So let's do this one a little bit longer. VD equals 100 kilometers, minus 60 is where it started. And then the time period, if you look at your graph, it finished there at 10 hours, minus 6 hours. So we have a difference of 40 kilometers in 4 hours, and we can see that the average speed decreased for the last part of the trip. So the question was, what is the highest speed the boat reaches? And it is 20 kilometers per hour. And there you go.